How does looking at distant galaxies allow us to look back in time? Hi there, and welcome back to our channel where we explore the fascinating and complex world of space and the universe. Today's topic is a particularly interesting one, and it's all about how looking at distant galaxies allows us to look back in time. This concept is one that can be difficult to wrap our heads around, but it's a fundamental concept in astronomy and astrophysics. So, let's dive in and explore this intriguing topic together. Firstly, let's consider the speed of light. Light travels at a constant speed of approximately 300,000 kilometers per second. This may seem incredibly fast, and it is, but when we consider the vast distances between objects in space, it becomes apparent that light still takes an incredibly long time to travel these distances. For example, the nearest star to our own Sun is approximately 4.2 light-years away. This means that the light we see from that star today actually left that star 4.2 years ago. In other words, looking at that star is like looking back in time 4.2 years ago. Now let's consider distant galaxies. Galaxies are immense structures made up of billions of stars, and they are located incredibly far away from us. In fact, some of the galaxies we observe are so far away that the light we see from them has been traveling for billions of years just to reach us. This means that when we look at these galaxies, we are actually seeing them as they were billions of years ago. It's like having a time machine to look back into the past. So, how does this work? Well, let's consider the light emitted by these distant galaxies. Just like any other form of light, the light emitted by a galaxy travels at the speed of light until it reaches an object that either absorbs or reflects it. When this light reaches our telescopes, we can study it in order to learn more about the galaxy itself, but we can also use the light to learn about the universe as a whole. Firstly, we can use the characteristics of the light to determine the distance of the galaxy. This is because the light emitted by a galaxy contains a unique spectrum of wavelengths that corresponds to the elements present within the galaxy. By analyzing this spectrum, we can determine how much the light has been stretched, which tells us how far away the galaxy is. This is called redshift, and it's a key tool for measuring distances in the universe. Once we know the distance of the galaxy and have studied its light, we can begin to piece together a timeline of what happened in the universe billions of years ago. This is because the light we are seeing from the distant galaxy was emitted when the universe was much younger and therefore has preserved information about that time. By studying the light from multiple galaxies, we can begin to build up a picture of how galaxies formed and evolved over time. It allows us to take a fascinating peek into the distant past of our universe. Moreover, studying distant galaxies also allows us to learn about the early universe. When the universe was very young, it was filled with a hot, dense gas. As the universe expanded and cooled, this gas began to form the first stars and galaxies. By studying the light from these distant galaxies, we can learn more about this process and how the first galaxies were formed. This is a key area of research in astrophysics, and the study of distant galaxies has already provided us with many insights into the early universe. In conclusion, looking at distant galaxies allows us to look back in time, providing us with key insights into the early universe and the formation and evolution of galaxies. By studying the light emitted by these galaxies, we can piece together a timeline of what happened billions of years ago, and learn more about the universe itself. It's a fascinating concept, and one that will continue to drive research in the field of astrophysics for years to come. Thank you for joining, and we'll see you in the next video. Thanks for watching.